Okay. So yes, what all topics we have to learn and what all we can cover. Let's see how many sessions it takes to cover in entire details about the Kubernetes. I saw that Kubernetes is a very popular topic. Most of the engineers today, they are trying to learn about Kubernetes. In all the organizations, already we have moved to the cloud. In software industry, having any solution over the cloud is now almost mandatory. And now the next transition which is happening is to run the applications into containers, and these containers are definitely hosted in clouds. So Kubernetes has become a very important topic. So let's begin with various introductory topics, and then we'll cover in what depth we can go. So first thing is, we'll discuss about what is the latest version of Kubernetes and what was it all about, right? So here Kubernetes is also known as K8s in short, because there are the Kubernetes spelling is like this. So K and S, the word starts with K and S, and there is 8 characters in between. So basically, Kubernetes is an open source platform. So other important thing we should understand is it's a open source product, open source software. It is container orchestration platform. So this is another important concept. So we will cover about this. What is container orchestration? And before that, I will also briefly cover what is containers. Containers are lightweight virtual machines. So I'll give you one story how I got introduced to containers. So this is about more than, I would say, 8-10 years back. So I used to work on various software applications. I used to develop applications on various platforms. So I used to work with JavaScript stack, where you do front end in React.js, back end in Node.js. I also used to work on Java stack, where few of the microservices I had was on Java Spring, and there were various databases. I used to use a lot of tools. I was always a person who used to use best in class development tools, because I used to be very sensitive or very I used to be very careful, cautious about building best quality code. So I used to use various scripts, lints, and various tools which could be desktop tools. I used to have my own Jenkins batch processing system, so that I can do various unit testing automatically and can work on uh, various optimizations of code. So the main challenge which I used to face was switching between various platform was very difficult. And sometimes, every 2 years in big industries, we have to change laptops. We need better machines. So I was always having to do a lot of setup work, installation work of my development tools. And in changing environment, when there was new development tools coming up, it used to be always a lot of effort to recreate the environments. So I used to also hire and onboard and mentor many engineers. So I also used to prescribe all the best practices and evaluations I have to do. I have to prescribe to others also. So it was always a repetitive work that we have to set up the environments again and again. So I started looking into various packaging software. Generally, when you install any software, you have to uh, run an installer, and installer will run on various different kinds of systems. So I thought that okay, if it could be faster way, so sometimes I used to copy in Eclipse some of the tools. If they are Java based tools, you can copy the jars, you can have a folder which you can copy paste, and you can recreate the environment very quickly. So I used to evaluate platforms like VMware virtual machines. Also, I used to work with VirtualBox, an open source tool. You can create an image of your development environment. But still, it was very difficult because VirtualBox was having a lot of overhead. So I was thinking what could be the best way. So I end up having a zip files, collection of zip files which had all my development tools and various applications, and I used to keep it in my instead of having an image in VirtualBox, what I started doing was I started having it in a pen drive, right? Pen drive, and now the pen drive also started coming with higher and higher configuration. And also I used to have a hard disk, but all these solutions, no, you have to copy the files, and sometimes they are not foolproof because operating system environments have multiple versions. They do change, and you may have a lot of applications already installed in some other environment. So this was not a very good solution because I felt that yes, carrying zip files and carrying hard disk and then transferring files and all was always not convenient. So there were a lot of packaging tools. So there were tools which can bundle applications together, because another problem is whenever you install any product, there are dependencies which are kept in multiple places. So for example, when I install any development tool, I may have dependencies. Okay, I see some people are waiting to join this call. Let me admit people. Yes, okay, perfect. So yes, whenever you install any development tool, there are files which are located in multiple folders. In Windows, for example, when you install, you may have files in the program files, and at the same time, you might have files in some temporary folders. You may have files in various other system folders. So this was always a challenge. So now what I did was no, because creating these environments, creating these zip drives were very tricky because you have to copy and then you have to put it back in also respective places. So then I started looking into, there are some packaging tools, and this way I came up with Docker. And with Docker, you can install applications very quickly. You can package, you can transfer, all your configuration is preserved. So that is something I started using for my purpose, personal purpose as well. And I also started sharing Docker containers with others, right? But yes, Docker also has some limitations. When I was working in Docker, the problem with not all the softwares are available for Docker as a Docker image. So definitely, no, I started deep diving into Docker so that some of the images which are not available could also be made. Docker generally supports all the applications which are available in Linux. But yes, over years it started that Windows container also started become popular. So then, I also started looking into various installation package management tools, and also have started porting many applications to Docker based environments. But yes, now the Docker community has also grown. So containers are now almost everywhere, and most of the headless applications are supported by Docker containers. So Docker is most popular container engine uh, which we can use. It does packaging of applications, right? So hope now you guys understood about what are the use cases, what are the advantages of using a package manager or a container which can have your usually which can have your development environment. So now next thing which I will be covering is that yeah, so we covered about what is containers. Basically containers are nothing, they are uh, a way to package your application, and it takes care of keeping your runtime dependencies together, right? Runtime together into single unit. So this is what is a container. Now next thing is next big things I already spoke about, that why Docker was useful for my development environment, because I can very quickly scale my team. So if my team is using 10 tools, I can create a Docker environment for each of these tools, and I can ask people to just replicate the Docker environment in their machines. This also helped the QA team also to also recreate the environments and applications very quickly. Now always there is not just single application which works in work for any solution. There are always multiple applications which are there. Say for example, if you are running any web application, you will need a database, you will need a web server, and you may also need web application server. So this was also my case with that I needed multiple such containers so that my entire solution can work together. So initially I started working with, there is something called Docker Swarm. So what it can do is it can instantiate multiple containers together, and you can manage all these containers. And definitely when I started using Docker, they were not that stable. So many times Docker containers used to stop running because maybe sometimes the resource crunch is there, or maybe some application crash. So it always becomes very tedious that how do I manage and how do I get good environment so that it is always up and running. So yes, Docker Swarm was something which was an orchestration engine which used to ensure that the multiple containers are deployed and they are running, and it takes care of reproducing the environment with multiple containers. So this is about the orchestration platform, right? So basically the advantage which I get from containers, so let me just talk about containers first, even before we talk about Kubernetes. I hope you guys are getting the complexities which these environments they kind of take care of, because the great thing which these environments does is they simplify application development. So just
Tarun, quick question can I ask?
sure.
Yeah. So Tarun, definitely we are using Kubernetes in the organization, but from my own development perspective, where actually I need to keep the chain my laptop. Recently, it had happened with me.
Yes,
So
yes.
I had to spend 3 days in order to set up everything, right? So
Yes.
does the Kubernetes, so does the containerize thing can help me to set up like IntelliJ IDEA and the web server and the code and the environment itself, right? So
Yes.
all those things, can I do this as part of container itself so that I can copy and right the image I can paste to some other machine, and then I can start working the same way on my laptop, the way I was working for. Can this?
Yes, yes,
Yeah.
right. So as I said that most of the headless tools are available in container format, right? So whatever you have to install, what you can do is you can go to the Docker registry, see whether there is a Docker version available for this particular software or not, right? So now you are talking about IntelliJ IDEA. This is ID, right? IntelliJ ID, which is a Java ID. Now see here, Docker registry. When I talk about, there is a Docker hub. Here in Docker hub, you will get all the Docker containers. You can search for Docker containers. So let me open that Docker. Yes. So Docker registry. Okay. So you can go here, hub.docker.com, and you can search any tool. So for example, if you are working on Java stack, you can search, there are Docker official images. So you have Tomcat available, Node.js available. There are a lot of tools available. There is OpenJDK tool which is also available. There is Groovy. There are a lot of tools which are available in Docker environment. Now say if I want to run say Tomcat environment in my local machine, is very simple. You also get this command docker pull tomcat. When you do that, you get the Docker Tomcat running in no time in your system, right? And there are various variations of these environment, because when I say docker pull tomcat, you get the most latest version of Tomcat engine. But there are other tags also which are available, so you can choose. For example, if you want a particular JDK Java version and a particular version of Tomcat, then you have so many different options. So instead of docker pull Tomcat, you will say docker pull this exactly the tag name.
Hey, Tarun, sorry for the disturb. I
Yes.
think, yeah, I can only see the MS Word screen. Yeah, the Google Docs screen.
Okay. Sorry.
Yeah.
Let me share again so that you see Docker Hub. Okay. Thank you for pointing this out. Yes. So yes, this is the Docker Hub which I was showing. So Docker Hub is available hub.docker.com. Correct? Now, see, many, as I said, tools are not available, and if I say IntelliJ, it is most probably not available, or yes, is it available? Okay, so you may have some versions, some of tools of IntelliJ. It's not the IDE available, because see, UI, when you use IntelliJ IDE, you are basically using a UI, right? And Docker container runs a very small version of Linux. So people who have played around with Linux, or it just runs the kernel of the operating system. So it does not have that front end libraries. So yes, early days in my college also, when I was doing kernel level programming, there are so many versions of Linux available. So now any distribution, Linux distribution, you can download very easily in your computer, because over the internet you can download. But I was talking about around 2000s, where the high bandwidth was not that great. But yes, then I have to get the CDs, and only sometimes some mini images are there which are lightweight, because when you install any operating system, if you are running two operating systems, you would not like to have a lot of unnecessary things. So in Linux, all the operating system is nowadays modular operating system. So mostly the Docker containers generally have the kernel level components. They'll not have the UI level components. So you'll not be able to run full IDEs on Docker container. But if something is running in the background, for example, Tomcat is a server, you can run it in Docker. Or so databases, for example. So yes, how you should plan your environment is definitely you have design time and you have run time. IntelliJ is your design time because you will use it only in the development. So what you will do in Docker, this is very important point you have mentioned. So we will focus on runtime of your application, right? In any application, if you see any architecture, you will have two kinds of architecture. One is in the design time. So in design time, you will be using an IDE, you will be using compilers, you will be using maybe some libraries, jars. So these are your design time of your application. Now runtime is what you would need to run the application, right? So for running an application, maybe you need Tomcat, you may need JVM, you may need a database. So this is how you should separate all your components into design time and runtime. Now see, in your design time, so for example, we have classified, assume we are having one application. Let's say we have a simple application, maybe a web application. So in the design time, maybe you are using Visual Studio Code, right? Or you are using say IntelliJ. Everyone has a different choice in this. So they can install this. But this is something which is not available uh, in Docker, right? But yes, again, developers can very quickly install these tools. So it's not a big deal installing IntelliJ or installing Visual Studio Code. This is not a big deal because you have a wizard which you can run, and in few minutes, hardly 10 minutes it takes to install all these. But what you should do is you should preserve your configuration of the IDEs. And there are also applications you can preserve your configuration, IDE configuration. So yes, you have the exe, or I would say the executable for IDE, plus what you also need is your configuration, right? Say for example, if you like some font size, you like some plugins which you are using, you should have these configurations preserved somewhere, and this you can share. You can always export these configurations and you can keep it and share your configurations with others as well. So this is one prescribed way of doing this. Now what else you need is you need compilers, right? For many compilers or linters, these tools you will get in Docker. So you can use Docker here. This maybe you can just do file export import. This is good enough for preserving your IDE configuration. And there are also team servers which are available, so basically the IDEs, they also provide some web applications where you can upload your configuration and you can import your configuration. So you don't have to worry about storing the configurations, importing and exporting, but that is also an option. Or you can use team servers for managing configurations, right? Now compilers, linters, these are also required. You can get the Docker images for this. So for example, if I see here in IntelliJ, some tools are available as a Docker image. For example, IntelliJ HTTP client is available for doing the testing, right? So if you are just requiring IntelliJ for doing testing, you can use it, right? Then they have some other components as well, right? Some people have done it, community have done it. So here you see IntelliJ desktop, so you can try it out. how they have done this, right? I'm not aware about, haven't used it this, but yes, there seems to be some people are access intelligent desktop via VNC viewer, right? So yes, this is what they do is probably, I think, when they are saying VNC viewer, so this is about remote desktop, right? So you may run your IntelliJ ID in some machine desktop, which could be located in your office environment, and then you can set up another environment to virtually connect to it and use it. Something like that could be there. So you can do that study about what this is, but I would say not that worth the effort, because this you can do very easily, right? But yes, maybe the compilers, you have to ensure that you are using, say, a particular version of JDK, right? So JDK 17.08 point something like this if you are using. So sometimes it becomes tricky, because if slight mismatch of these numbers may result in some some different class library not available, or there could be some breakages because of slight mismatch of version. So npm, node.js, these things you can install in Docker containers, right? So again, these are also design time and these are also runtime. Some components are both design time and runtime also. So here, say for example, for runtime, you don't need the JDK, you just need the JRE, Java Runtime Environment, right? Similarly, yeah, but in Node.js, you may need Node as well as NPM, right? So this you have to divide the components into design time and runtime. Then you will definitely need a database, right? So for example, your database for development could be MySQL, or maybe it could be Oracle, right? And here maybe for testing purpose you may be using HBase, some very light in-memory database you may be using. So there could be possibility that you have a in development environment some different database, and in production environment some dedicated database. So basically your design time architecture will be different and runtime architecture will be different, and all these you can have it into multiple Docker images. So what initially I used to do is I used to create all my components into one Docker image, right? So that is one option, that I have the database also in the same image. I have the compilers also in the same image. And then I used to call that Docker image as my own application. But this is having problems because one, it becomes very complicated. It don't provide you a lot of flexibility, and there is a single point of failure. If the Docker container stops running, everything is stopped in your system, and it's more likely to be failing because your single container is having lot of applications, so it is requiring a lot of resources. And if you start running multiple containers, or if you are running some heavy applications on your machine, then the Docker will keep stopping abruptly, and this will be very irritating. So then other thing what I started doing is I used to have a separate machine for running my Docker containers, right? And separate machine where I'm running IntelliJ IDEA editor. Also we use a lot of other applications also, for example PowerPoint, Outlook, Word, for doing documentation, for doing some other official work. So they are also very resource intensive applications. So they also, if you are running it in your same machine where you are running your compilers and environments, will bring down the Docker containers. So then this way I used to have a separate machine for doing Word and other Office 365 related applications, because yes, in our work we need to do PPTs, we need to do a lot of Word documentation, Also, we need to reply to emails, so Outlook is also running on your system. But yes, if you keep these, so then what I started doing is I used to start creating different Docker images, one for databases, one for application server, and then I used to start connecting them with something called Docker Swarm. Right, so there was a very nice application which was available, which was called Docker Swarm. So when you run Swarm, it used to create a cluster of Docker. So I can have one Docker image running JDK, one Docker image running Tomcat, one Docker image running database, etc. Right. So this is all about orchestration. So yeah, now you would have understood that there is always a need of orchestration, because we need multiple components to design any software application. Right. So basically the advantage, now let's talk about the benefits of this containers. So definitely the benefit is you get consistency, because once you create a Docker image and you upload the Docker image, this image is replicable. You can reproduce it any number of time, and in few seconds you can reproduce it, because running a container is very fast. It will be happening in milliseconds, not even seconds. It will be running very fast. So this is one advantage. So you get consistency, you get very easy reproducible environments. Correct. Now, if you are using a single container, you get this. And if you are using a cluster of containers, then with orchestration tools, you get this consistency and reproducibility also. They also provide isolation, right? So because it may happen that you want to run, say, HBase database, you also want to run MySQL, and you do also want to run Oracle database. See, if you want to run these three different kinds of databases, sometimes it's not possible to deploy two applications together, because there could be some conflict which may happen. So if I install MySQL and then I install Oracle, it can happen that when I install something, there is some conflict, and both the applications I can't run at the same time, right? Sometimes some resources are being utilized, like port conflicts we get to see a lot of times. So when you run Docker containers, these Docker containers can run always simultaneously, because they are isolated from each other. And there could not be any situation where something in one application is conflicting with some other application. So this is another benefit. And definitely portability is another advantage. Say, assume I am running Mac, you are running Windows. Now I can't share my components, because yes, earlier I said I used to create a zip pen drive. I used to have all the zip files of my development environment into pen drives. I used to have a small readme file where to put all these zip files, and this way I used to create environment. This was prior to Docker. After Docker, now what I do is I create a Docker image and I keep it in Docker registry. And anytime if I have to install it, I can install it. Now here I can do it in Windows, I can do it in Linux or Mac as well, because Docker is available in all the platforms. And if you have an image is going to be running in all the platforms. So that is another benefit. And best benefit which I got was I need not have to install Linux for many tools. I used to use many tools which were Linux based, but yes, in the company laptop I used to get Windows operating system. So I can also create a small tiny Linux Docker image, and on that I can try it out all the Linux commands as well. So the benefit is lightweight. Docker also provides very lightweight operating system kernel which can be run in isolation. Great. So there are more benefits. If you want to, so Docker files, when you create Docker files, Docker images, they are basically textual commands which you create. So they can be versioned. So your Docker images can be versioned, and you can reuse also Docker images, because once I create a JRE instance, in many application I can use that same image. If you create a Docker database image for HBase or for MySQL or for Tomcat, anything, you can reuse this also. You can have multiple versions of any software running, and you can have multiple versions of your configurations as well, right? And they are definitely, all these advantages are very much required for building microservices. So they are convenient for building microservices, right? So this is nowadays the best advantage, because I have already demonstrated that how to run multiple microservices in other sessions. Maybe I will share these sessions also again with you, so that we designed some application microservices and we run it in Kubernetes cluster also. So that practical session I have already covered, but I wanted to cover what much beyond practical concepts. So that's why I'm going. I want to cover a lot of theory, because everything, if I demonstrate, it will take a lot of time. But yes, if I can do a theory, you will see all the possibilities. Then we can cover one by one various practical aspects as well going forward. So basically, yes, Docker was a good thing for me, and this came after 2013. So earlier to that, it was hard life for me. I was evaluating various one-click installers. There were some one-click installers available, but with limited number of applications running on that. Okay. So yes. So this is, containers are lightweight virtual machines. So yes, you should understand that it does not contain full operating system. It is a small kernel only. So you can't run all the applications on this. Now let's talk about orchestration, because I talked a lot about containers. Now let's talk about what is container orchestration, because that is another term, because other things you understand. See, it's when you have multiple Docker containers. Now we are getting multiple Docker containers. So the problem is you have to start and stop various Docker containers to make your application running. Again, I gave an example of a small web application. If you have a web application and if you are storing information in the database, you cannot run your application until your database is up and running, right? So it happens a lot of time, and it has to run, database also has to run in a particular port, because your application can connect to it. So there could be some configuration which is required. Maybe you have to enable, disable some additional features in your application, in your database, or in your platform. So there could be multiple steps which you may have to do, right? Because maybe you have to install and start Tomcat, but at the same time you have to put some jars, you have to deploy your code into that Tomcat web folder. So all these activities are there. So the orchestration program, orchestration. So now let's talk about benefits of orchestration. So benefit of basically container orchestration. So here there is also message orchestration. That's a different thing. But here we are talking about container orchestration. You should not confuse it with orchestration platforms like Kafka. Here we are talking about Kubernetes, and we are talking about container orchestration, not about message orchestration. So here what it provides automation. That's one advantage. Definitely you get all the advantage of containers in orchestration platform. I gave one example of orchestration platform, which was Docker Swarm. Why I went with Docker Swarm initially was because Kubernetes was very complicated in the earlier days. Now it has been very much simplified. And Docker Swarm was very user friendly. It used to have a very nice UI, and you can see all your containers running as boxes, and you can very easily configure using drag and drop, and various mouse UI based editor was there to configure various containers and connect with each other. So this was very convenient for maintaining my infrastructure. But nowadays Kubernetes is lightweight, easy to use, and is more powerful because it has much more features. Docker Swarm don't had that many features as Kubernetes has at this particular time. So I will recommend, don't worry about this. This is mostly now became obsolete. What we can directly jump is into Kubernetes, right? And yes, so here automation of what? Automation of deployment. Now when you deploy in development environment, less challenges are there because you may be running one instance only, but in production environment you have to scale. So you need automation in scaling, so dynamically adjusting the number of containers. It can load balance also, right? So you get all these benefits. When you are running Kubernetes, you get automatic deployments of container because Kubernetes manages the containers. It can do load balancing because if you have to run highly available application, you can do load balancing. You can scale it automatically. Any questions?
No, that's good.
Right, perfect. And then you can also do network configurations automatically here. Definitely. You can do service discovery. Right, so we will cover in Kubernetes, you create services, and these services are logical names. So you don't have to interact with the IP addresses, or you can just interact with the services. So service discovery is also possible. You can also get health monitoring, right? So you can monitor containers and services. Services are something which is running on container, is called services. And you can monitor that whether your container running the database or container running your Tomcat is healthy or not. And this can also do resource allocation. That means you can specify how much CPU to use, how much memory to use, and any other resources like hard disk, etc., how much to use. Because see, as I said, containers are virtual machine, and virtual machines are powerful only when you can configure how many CPU to utilize. You can change the CPU percentage, memory percentage, and hard disk percentage based on how demanding is your application. Then a lot of security features are also there, which is again needing in the production environment. Right, see, and also one more important thing, This is basically your design time is development environment, right? It could also be testing environment, right? But we generally prefer testing also to be very close to, yeah, I would say unit testing. It could be unit testing or integration testing. Runtime environment is something which is your production, right? Again, you may have different kinds of runtime environment in various scenarios. For example, I may have a different runtime in feature testing, because if the feature is not touching all the aspects of my application, I may not deploy all the components, right? Production environment, definitely I'll use entire application, and this could also be used for some testing. So this definitely, I would say, acceptance testing and production environment will be very close, right? So here these are various benefits, and you may need different kinds of resource allocation for different kinds of environments.
Tarun, your Google Chrome screen is visible. Yeah, maybe you are on another screen. You are want to show us, but
No,
I
I'm
can
into
only show
Google Docs. I wanted to
Docker.
just
Okay, Docker
yes,
Swarm is written. Yeah.
yes, right? So
Okay.
maybe some lag could be there, but yes, I just want to share these notes because these are the topics which I'm covering, right? So these are so I spoke about container orchestration platforms and their benefits, right? So there is another important thing, because see, you won't be running, starting and stopping these applications all the time. Best would be, because yes, there was another problem which I used to face as a developer was every morning which I when I used to come to office, I used to start all these, maybe start the database, then start the Tomcat, start various components, right? If you switch off your computer. But best would be if you don't stop, you keep running this forever, right? Maybe only once in a month or once in 2 3 months you have to restart these things. But yes, when you do such kind of environment, you would need to update these applications. So these also provide rolling updates and rollbacks. Now, what does rolling update means? Can anyone know? Can anyone tell what is rolling update?
Update in terms of images, like which the image that we are using for our Dockers.
Right. See, whenever you update, for example, assume you are running an application on Tomcat. Now, assume you have added one more feature. So you have compiled a new jar and you have to deploy something new. When you are deploying a new jar, you will have to restart the Tomcat server, right? So there is a downtime. So rolling update means updating without downtime, with zero downtime. So this is rolling update, right? So what actually orchestration platform also support is that if you are running multiple clusters of the environment, so when I'll be running Tomcat, I may be running 2 instances or 3 instances of my Tomcat server. So when I will deploy a new jar, the Kubernetes will take care that it will not deploy at the same time in all 3 instances of the cluster. It will install one by one. So once it will install, it has health check monitoring. So it will know once the deployment is finished, and until the deployment is not finished, it will not route any request to that particular instance. So this way you get zero downtime because you do updates one by one in all your instances of the cluster. So your application is operational throughout, even if you are updating your code in the environment, right?
So, Tarun, does it mean the load balancer that Kubernetes comes with, we supposed to use the LB of the exposed by the load balancer, exposed by the Kubernetes instead of the extra load balancer. Is that something we should go
Yes,
with this
yes,
type?
right. So when you have the container running, you can use external load balancers also. But yes, here mostly, we will be talking about using the load balancer which comes with Kubernetes platform, right?
Cool, sure.
So you should understand that load balancer is something which will be required. Say if you are running, say, microservices, your application is assume is made of 10 microservices. So how many load balancers would you need? Right?
Yeah, exactly.
Multiple, because you may
Correct.
have an API gateway also, but for each of the microservices you would need load balancers. So better to have a load balancer which is used by the platform. Again, we should understand that what we generally speak when we say load balancer, we always talk about load balancer which is there in our gateway, right? But yes, definitely you need multiple other load balancers also in microservices architecture. You also need load balancers for database, because when you have a cluster of database running, there will be multiple instances of database running. But yes, many times again database platform provide that load balancing capabilities. So here when I talk about load balancer, I'm talking about Kubernetes uh, load balancer which is available in the platform natively, right? But yes, definitely you are free to choose external load balancers also, and generally you use external load balancers only at the gateway level. See, there is difference between rolling updates and rollout and rollback. So there is another term, will I would say, since I use the term rollback. Rollback is something, if you have a problem, you can roll back to the previous version. So this is another important feature which is available in Kubernetes, that you can roll back, and this is very straightforward. But yes, if you do manually, it is not straightforward, because if you have deployed, then you need to know what all things have been, what all dependencies were there, and what all impact was there, and you have to carefully ensure that everything is rolled back. But in Kubernetes, it is automated, it is convenient, it's very straightforward. So you get easy rollbacks, and rollout is anyway, update is a rollout. But when you deploy anything new, you may choose not to roll out immediately because you may want to verify it. So rollout and rolling updates, there is a slight difference between these two terms. Rolling updates is just doing the updates so that your environment is having the new jars. But rollout is exposing it to external world, which you may not do immediately because maybe you need to ensure that everything is running well. So you may do some verification testing internally, and once you are fully sure, you can roll out. So you can roll out gradually using container orchestration platform, and if things are not good, you can roll back also, right? See, rollback is easy because it does not do everything at once, so it knows what was the previous state. And roll out gradually you can do, so that if not all users are impacted at the same time. Maybe we will cover, I will share another article link I have written in depth about various strategies. Say for example, blue green deployment straight. So there is set of microservices deployment patterns. I have written a detailed architecture about it. So blue green deployment, canary deployment, there are various strategies for uh, deploying and rolling out microservices. But yes, again, we are not going in depth. But yes, all these are supported by Kubernetes or any container orchestration platform. If I have to give a list of container orchestration platforms, so I will talk about, I have already talked about Docker Swarm, right? Kubernetes is another container orchestration platform, right? There is a lot of other platforms. So there is Apache Mesos, right? This is another platform. And there are few more container orchestration platforms which are competing with Docker or with Kubernetes, and also sometimes uh, some container platforms are based on Kubernetes, because as you know, Kubernetes is an open source platform. So these are benefits of platform. Now let's move on to next topic. So we were just covering about the basics. So now let's talk about the architecture of Kubernetes. Right. So currently, I believe the most recent version of Kubernetes is 1.28. Right. So this can be very easily checked. Kubernetes has a website which is kubernetes.io, right? So this is Kubernetes website is there. Now you can learn a lot of things here. So as I said, it's known as K8s, is an open source platform. It automates deployment, scaling and management of container applications, right? So here, if I have to know about the latest version, I can just check the documentation, and in the latest version, whatever is the latest versions here is, yeah, 1.28 is the latest version. So here I can see the latest version. And yes, definitely I'll cover all these things one by one in practical also in the later sessions. So basically you understand that knowledge of Linux operating system is important here. So if you are not aware of Linux, better refresh on Linux concepts. Also knowledge of Docker is important here, and we will also cover how to deploy Kubernetes over AWS or any other cloud. So some cloud familiarity is also important, right? Now in fundamentals, so fundamentals, as I said, when you have Kubernetes running in your local machine, I will also share how to run Kubernetes in the local machine. I have mentioned it, I have an article on that. I have also shared it in a previous session how to run Kubernetes, so I can share the video recording of how to install Kubernetes on your local machine. So basically Kubernetes, when you have, you will be having a lot of deployments, you will be having pods, you have definitely containers, you have here services. So there are various building blocks of Kubernetes. So let's call it building blocks of Kubernetes.
So we are not able to see if you're typing something here. Right? Share.
Oh, the Google Doc is not there visible?
No.
Okay, maybe my automatically it got stopped the screen sharing. Let me do the screen sharing again. Hope now you should be able to see. Right? Yeah, I think the
Yes, we can.
presenting got stopped. Great, nice to share me. So basically, yes, what you will be learning, what we need to cover is what are pods. So very important thing is when anything which is deployable, smallest deployable unit is called pods in Kubernetes, right? So this is the smallest deployment unit. Pod can contain one or more container. That's why it's called container. It can contains more than one container. But yes, it is something which is a smallest deployment unit. Now see here the Docker uh, has the logo. If you see the logo of Docker, something it's a whale, right? So the logo of and group of fishes is called pods. So it's very easy to remember. So yeah, this is the Docker logo. So pod means you have multiple containers, right? Now there's something called, so containers we know. There is another term which I have to say. So basically let me reorganize all these things so that we are discussing. So we discussed about containers already. Okay. Yes, so that's one thing. I'll remove this image. Yeah, because now you understand why it's called pods. Containers. Then next thing is you have something called node. Node, that means node is nothing but virtual machines, right? So you may be running multiple virtual machines on a single physical machine, right? So basically nodes are nothing. It could be anything. It could be some virtual machines basically where you are running containers. Collection of node is called clusters, right? So this is another thing. Collection of nodes. So basically set of nodes is cluster. And then you have pods. So basically pods will have multiple clusters. And when you have multiple clusters, basically clusters will be providing some services. So think of, there will be some microservices or services which will be running. Services is a logical concept. So basically it's an abstraction for set of pods, right? Correct. So these are various building blocks. And definitely you have deployment. Deployment is basically services. You deploy multiple services, but deployment also includes configurations, right? So it's basically deployment is your I would say deployment is the largest entity, and this is your configuration plus services. Now, how would you store configurations? Definitely, you will have a lot of things. You have config map, you have secrets, and there are a lot of features which are available with Kubernetes. I can't list them all because yes, there are many. We will cover them. There are concepts of labels, selectors. We'll cover. These are simple connect. So labels are nothing. It's like key value pair, right? So you can assign, since you are managing so many containers, you can give key value pairs to each of these entities so that you can easily refer them. Then you have selectors. Selectors are just deploying to some selection of uh, subset of resources. So basically, these things are resources. So yeah, let me put here resources. For resources or infrastructure items. And then you may have also resources for storage, which could be persistence, volumes, right? So you will be running containers, and at the same time you will be having some storage also, CPU plus memory, right? Memory, or I would say storage. Memory uh, can be confused with primary memory. So yes, these are various various building blocks of Kubernetes. We'll be covering. You'll understand it better when I show it practically. One more benefit, Kubernetes also provides logging, right? So you can very easily log what all is going on. This is also important. Basically, Kubernetes also integrates with various logging and monitoring tools like Prometheus. You would have heard about it. So there are various other third-party tools which works very well in Kubernetes. So there are a lot of extensions. For example, Helm you would have heard of. There are various plugins available for various things. So there is a very big ecosystem of Kubernetes related third party solutions, and these solutions could be on various aspects, could be on observability, logging, monitoring, it could be on package management, it could be on networking related items, integration related items. So that is another benefit of Kubernetes' third party ecosystem. Right.
I Tarun, so ham chart is for logging or is for configure Kubernetes clusters?
Yeah, it is for uh, package managing
Okay,
Kubernetes, right?
the package manager.
Yes, it's a package manager. So I've just said that there are various plugins. Yeah, I should put here. I created here a separate third party ecosystem. So ham. Yes. Yes, right. Thanks for pointing it out.
Okay, and ham chart both are same. Or is some
Yes,
difference?
yes. See, the charts basically they are collection of resources, right? So yes, ham chart basically is a package of pre-configured Kubernetes resources, right? So basically you'll have templates,
Mhm.
and templates will have template files, manifest files, and that's how you kind of configure anything. So ham is a package manager and it has a repository, and the format in which ham is packaging all the resources is known as charts,
All right.
right? So yeah, that's another. There are so many advanced topics, right? We have to cover, but yes, let's do it one by one. I will introduce all these gradually,
Yeah.
because yes, I am planning multiple sessions on it. So yes, today we will just, this was the first session, so we covered few items, and definitely we will cover going forward. So ham is one thing, another stuff is ingress, right? And ingress is for service mesh. Then We'll be covering definitely about, yeah, we'll cover about something. I'll cover about serverless computing. Also I covered, I already gave a session on it, but how do you do serverless computing using Kubernetes, basically, how it can help in serverless computing. We will learn in later chapters. And Kubernetes also have something called, so APIs, plugins. Basically, when I say third party ecosystem, it is APIs. There are plugins also. Kubernetes platform has APIs so that you can build plugins. You can write some custom code also for yourself, and you can also have webhooks. If you are doing automation, then these are helpful, right? So basically we were talking about Kubernetes. Latest version is 1.28, but yes, you would need to install Docker also, the latest version of Docker. Maybe before the next class you can be ready to do have a system Docker environment running in your system. The website I will give to install Docker, it is called, you can just say get Docker in Google. You will get the website to install Docker. Now see, Kubernetes is a platform uh, which is not a single installation. It is consisting of multiple items. So to install Docker, what I would to install Kubernetes, what I'll recommend, use Minikube. Minikube you should install. Minikube is a single node cluster, Kubernetes cluster. Basically, Kubernetes is a technology which is a cluster, right? So you should install that. To install Minikube, I will again give website. So because next time we can start doing practicals on it. So this is the site for installing Kubernetes or Minikube, basically. Yes, Minikube is good for learning Kubernetes. Because yes, you don't have to worry about installing Kubernetes most of the time, because Kubernetes is available in various cloud platform, right? So you should be having Kubernetes running on your system, and for running this you need a Docker container, right? So here it is giving, so it supports so many other container technology. So this is list of container technology, but Docker is the de facto standard mostly. So we'll focus on that. And then so yes, we should also install ham package manager. You can install Prometheus. We'll be covering. I'll share. But right now, don't worry about all these things. As in when we will be installing, we'll be covering Prometheus and Grafana. These things, yes, we can install. Install Python also. So yes, that's also one thing which is fundamental. So you should have Python running. If you are running MacBook, don't have to worry about it. YAML, mostly all the configurations which you create in Kubernetes are done using YAML. So YAML is another important topic. So these are the topics you should be aware of for Kubernetes, right? So I have shared all these. Maybe I'll give you in next time a Kubernetes architecture. So I'm just talking about, yes, maybe in the next class we can discuss on installing all these items, right? Not all these, few of these, 2 3 basically, and how to use this. So basically getting started with Kubernetes, Docker, we will do that next time. and then we will also do work about probably architecture of Kubernetes. Components we have seen. So these are basic building blocks and components. I have introduced you what each of these means, but then how they are connected and what is the overall architecture, I'll share. Because there are some control nodes, multiple nodes are there in Kubernetes, and then we'll look into, maybe when we will be doing some example, we will look into what pods are there, how we can select pods, how we can label pods, how we can configure pods, containers and deployments, and how we can define deployments, how we can define these building blocks or components of Kubernetes. And once we have defined multiple components, we'll take this example only of a simple web application where we may need a load balancer, we may need a web server, we may need a web application server and a database. Right? Sometimes we also need caching, a cache component. So yes, see already so many pods or nodes I have shared is required generally in very simple applications. Then we can, once we have all these the database, the cache, the web application server, web server, load balancer, then we have to manage resources for each of these components, and we have to orchestrate these. So that means that until unless your database is not running, do not start the cache. Until unless your cache is not running and up, do not start the application server. Until maybe in application server you have multiple microservices, and each of these microservices will be having dependencies on each other. So see, it's so complicated thing to manage any application, and Kubernetes helps a lot because it can orchestrate. So you may have, say, one microservice which is, say, order management, another one shopping cart. So you may need to run a shopping cart microservices before you can start the order management, and so there could be multiple dependencies, so you have to orchestrate. And if something goes down, you should create another instance of the service, or if load increases, then you have to maybe create more containers. All these things you can define through rules using Kubernetes, and this is called orchestration. So basically what we are doing is we will be doing horizontal scaling. So all this is about horizontally scaling, and not also scaling. Generally in Kubernetes we use the term auto scaling, and we do the scaling of pods because pods are the smallest deployable units. So this will cover. So we will also cover about storages, because you would need storages. Suppose you have some application where you're storing files, then how do you manage storages? That is also important. And as I said, we will be covering serverless computing also. And if you have viewed my if you have attended my session on there was a session on microservices architecture patterns, so then you would have also known about service mesh. So very quickly, what is service mesh? So service mesh is basically if you have multiple services, then managing which service to call, managing the communication between services becomes very difficult. So service mesh is something which helps in service discovery. Basically it does the service registry. It is a service registry. It is a service mesh. It does load balancing. It does failover, circuit breaking, monitoring, security. So it's again another infrastructure for running microservices. So we'll be covering about service meshes. right? So we'll be discussing that in depth also, because this is basically used for traffic management between various services, taking care of service discovery, service registry. What it is, I will cover later.
Okay. Okay. So Tarun, in the Kubernetes terminology, like you mentioned, there are
Yes.
pods and yeah. So containers. So containers. So if I relate with Docker,
Hmm.
yeah. So Docker means like if in my web application, if I am using Redis, MySQL, or a Node, yeah, for example.
Yes.
So and I am running Node in a separate container and Redis and MySQL in in another
Yes.
separate container, and
Yes.
I'm using Docker desktop just to
Yes.
like yeah a place where I can uh, where I can up and down
Correct.
the Dockers, yeah.
Correct.
So okay, so the first term, that is container. Container, it means I have three containers, one for Redis, MySQL, and Node.js.
Yes.
Okay, and after that, we have next thing is Node. Node is Node VM. What is the
Yes.
second term
Correct.
you?
Correct.
Yeah.
Absolutely. VM.
So okay, so VM. So VM is something. It's is my Docker desktop or is my Docker?
Yes. See, your Docker container is container. Correct.
Yes. Huh?
Now you have decided to run only one application in the container, which is Redis.
Okay.
You may decide to run multiple application on the same container.
On the same container.
Yes. So in the same container, you have Redis. Maybe you can
Mm-hmm.
run something else as well.
Okay.
Right?
Yes.
So, or you can run these nodes in single machine, single physical machine, assume, or
Yes.
you may run these in multiple machines. So node is basically your laptop,
Okay. A machine.
right? Yeah, is a virtual machine or a physical machine or basically a machine, right? Node is a machine. You may be running multiple containers in a single machine also, or you may be running one machine, one container, right?
Okay. And cluster is set of nodes. It means set
Yes.
of different VMs. So in that scenario, so the Redis, MySQL, and the node, there are three nodes, three nodes. It means this is one cluster.
Yes, yes, absolutely, absolutely. See,
Okay.
cluster will be, now we will be using this because mostly the deployment happens in cloud.
Mm-hmm.
So there will be multiple, say, EC2s,
Mm-hmm.
right? So you would have a cluster of Redis because if one fails, your application is down.
Yes.
So you'll need multiple Redis, one for backup, one for disaster recovery, one for load balancing. So all these is a cluster, collection of all these machines, and definitely when you are having backup and disaster recovery and scalability, you will be doing it in multiple nodes because to have more fault tolerance, right? So then that is your cluster.
Okay. Okay. So it means okay. So if I relate this in practical example, so okay. So while writing, while configuring the cluster, I have to, or maybe I can write my 10 Redis instances where one
Yes.
instance is for writing in and one is for reading. Yeah,
Yes.
okay, this kind of thing
Yes,
I
you
have
can
to
configure it.
I have
Yes.
I have to configure. Okay.
Yes. So all these information you will give to Kubernetes, and Kubernetes will use all these policies and will manage or orchestrate your infrastructure resources based on the policies which you have given. This is Kubernetes,
All right. Got
right?
it. Yeah.
Perfect, perfect. Yes. So,
Okay. And
and then you have services running on these clusters, or you have plots, because definitely you will have the same deployment. Your code needs to be deployed in all these environment, and then finally you should run some services. So all these things are there. So there is one more topic. So we say Isito, right? So this is another tool which we may cover, which is again for managing services.
okay. And and why do we need Python here?
Yeah, Python. Yes, this.
Because YML I can
Yes, you
relate
would
with it
need. You'll
to
do mostly here. Yes,
okay.
Python. Yeah, you may not need Python. Yes, this is the right input.
Okay.
Yeah, because just uh, no, maybe I thought about something which I forgot.
Mhm. Because I
Yes,
think
some tools are internally dependent. So basically, I'm talking about runtime. There are some tools which are Python based. You don't need to know the Python programming language. You need to
mhm.
have it running in your system. Pip
Okay.
package manager or some things. I'm not exactly recalling, but yeah, I feel that this is required. Python runtime is required to have these tools running, up and running.
Okay.
Right? Maybe Minikube, or they have internally some tools which are done using Python, and they require Python runtime. Yeah, so this is not design time, this is runtime. Yes. And
Okay.
yeah,
Okay.
because definitely this YAML you are writing, someone would be interpreting it, right? So yes, you need some environment here. Okay. So yes, we'll discuss about security challenges in Kubernetes, because you get lot of benefits, but you get some drawbacks also. So we'll cover that also in upcoming sessions, and we will also cover about future trends, right? In Kubernetes. So this is what all we will be covering in Kubernetes in maybe 2-3 sessions with practicals, right? Wherever possible. Because see, when we will be doing these practicals,
Mhm.
you will not only learn Kubernetes, you will also learn microservices architecture, and it will also give a very solid understanding of system design concepts.
Yes.
Because with Kubernetes, it is like you are building your entire network infrastructure or data center for yourself using the cloud environment or your local machine environment also. So yeah, you can run multiple microservices in your laptop. If you have a 8 GB RAM laptop, is powerful enough to run multiple simple microservices, 4 5 microservices. It's good enough to run. I have run I had a message broker, I had cache, I had database, I had application server, everything running in single laptop, right? And when I say microservices, multiple instances, 2 instances, 3 instances of microservices in the single laptop. So you can play around, you will get full understanding of system design. You can design an entire software system in a single laptop using Kubernetes, because you will be creating different Docker containers for each of them, and you can very easily orchestrate all these Docker containers to give services. So we'll cover that.
Okay. Yeah. Because I don't know much about the microservices, but I want to I want to know how the different microservices will work together and get the access token. Maybe like if one microservice is for adding the product and second one is for getting the product. So
Yes.
how the one is using the authentications, yeah, and
Okay.
the second one is getting how the second one is sure that the that user is requesting for the fetching the product that he just added.
Yes,
Yeah,
yes,
because in a single node, yeah, I can just ask for the like I have a token and I can decrypt. If, I'm not sure how the microservice will work in this scenario, but single I'm aware about, like, yeah,
okay, yes,
JWT. I can decrypt JWT and I can get the
yes,
user ID. Yeah.
yes,
Okay.
correct.
Is this the same functionality we also do in microservice, or is there any different concept in microservice to get the
Yes,
identity of the user identity?
right. See, here in microservices, what you have to take care is, if you have say 10 microservices,
Hmm.
then you have to do authentication in 10 different places,
Okay.
which is too complicated, right?
Yes.
It's repetitions, so
Yeah.
which is bad. What you can do, you can create a API gateway.
Hmm.
All the calls will go through API gateway. You do the authentication. In case authentication fails, you do not forward the call,
Okay.
right?
Okay. It means say API. Okay. API call would be there just to check
Yes,
the authentication.
yes, right. API
Okay.
gateway is important here. So you can do it in a separate microservice or a API gateway which can take care of authentication. Right, so
Okay.
some applications also have a separate authentication component, and based, so everyone is dependent on authentication microservice, and once authentication is successful, then you allow people to proceed further with service calls. Otherwise you block the person as not authenticated.
Okay, so Tarun, in that scenario, it will not increase the latency because you have to call first microservice just to check the authenticity of the user, and then you have to call the another microservice is for fetching the information based on the auth
Yes,
information.
yes, right.
Yeah.
See, security is always will bring latency,
Okay.
right? See, security is important, but little bit of security check is important, right? In airport, same thing, right?
Yeah.
Security check is wastage of time, but it's still important. We have to go through that.
Yes.
So it's same here in authentication also. It's something which will have overhead. You cannot remove that overhead because you have to do the check, authentication check, right?
Mm.
And if you have to do authentication check, there will always be overhead. Whatever you do, you will always have the authentication check, overhead. Only way to reduce the overhead is not to have the security,
Got
right?
it.
Which is also not advisable. So you have to have the overhead. But yes, here see, I am doing it only once in a API gateway. If I don't do in a API gateway, then I have to authenticate otherwise in all the microservices, which
Yes.
will be more overhead,
Absolutely.
right? So this way API gateways help in improving the overhead.
Yeah, absolutely. Yeah. So might be in a later stage, if we need to change the authentication services, then we have to change in all 10 microservices.
Yes,
Yes.
yes.
Yeah.
So which will become very complicated in
Yeah.
maintenance phase.
Absolutely.
Yes. So,
Awesome.
so this way you will have, and you can do a lot of things in the API gateway. There are a lot of cross-cutting things. For example, logging, caching, right? So there are tens of things that is taken care by API gateway,
Okay. Yeah. Great. Okay,
right?
Tarun.
So
So I think that's great. Yeah, but like while doing this Kubernetes series, or yeah, so can we do something like parallelly, like run a project where like we can use as a real APIs and use those different containers and how a real product should work. Yeah, instead of just going through with the concepts and just like maybe you can like I know that you will initiate some mini cubes, some containers on your
yes,
machine,
yes,
but yeah,
yes.
but as a part of the whole project, yeah, can we do something that maybe on a GitHub, like we can set up something and like how the best practice is followed, or we can integrate the APIs, or integrate and use all the concept that we will discuss in this Kubernetes series, and we will implement all those things in that project. So that something is practical, but also is a
Yes,
real
yes.
implementation also.
Right, right. Let's. What do you think?
Yeah,
A bookstore, online
I'm
bookstore,
available.
something like
Yeah,
that we can do. Yeah.
yeah, absolutely. Any project, any application that is, because like right now I'm part of the scalar program. Yeah, you are, you know about it,
Yes, yes.
and you are my mentor there. Yeah, so yeah,
Correct.
so right now high level module is going on. Yes, and in this high level module I am working on to Java Spring Boot. Yeah. So initially, I have experience with the mobile application, but in Scalar, like they are teaching us Spring Boot. Yeah, and yeah, and now I'm good in Spring Boot also, because I have implemented different REST APIs,
Correct,
and
correct.
now there are upcoming classes in Scalar where we will do we will use Kafka and these Dockers, like the real a microservices pattern. but
Yes.
but I but as a practice, I also want to like practice these Kubernetes, Docker, Kafka in terms of a project. So like online bookstore, online game,
Yes.
any examples, any set of the, like we will start from, like can we do something, a real project, start from the LLD and writing, because I know that this will take
Yes.
a very long time. Yeah, I know, but uh,
Right. Yeah, and I'll keep these simple applications because these are simple applications. So,
mhm.
with the simplicity of these small scoped application, we can do it
Okay,
during
great.
1 hour sessions, maybe in 3 4 sessions this could be done. I just kept one more as a backup because sometimes some concepts cannot be demonstrated with one say for example no message queues, right? So that's why
Yes,
I kept online game or some other another application also as a backup. One or two applications we can do so that we can cover all the concepts which we are discussing and we can see them practically.
sure.
And
Yeah.
I will create a GitHub project also which will I'll share the code also for your everyone's reference, easy reference.
A reference, or maybe like in our session, if we just discuss something, and maybe as a refresher, if we need to write one more services just to test what we learned. So maybe like as a homework that I can, or maybe like all the people, they can design that web services, that REST API in their
Yes.
own code, and they can just raise the PR. Yeah. So maybe your code will have everything, and also the other people are also contributing. Yes.
Correct, correct.
Yeah.
Okay, yeah, this is a
Yeah.
great idea. Yes.
Yeah.
So that no, we can kind of invite people also to some exercises I can give you so that
Mhm.
you can code and then not everything I complete,
Yes.
maybe 50% I complete or 20% I complete, rest of 80% you guys do. Right?
Awesome.
So
Great.
this will be kind of a group project so that we can learn all these components. We can do this with Spring Boot
Mhm.
or we can do it with Node.js or any other tool, whichever people are compatible. But yes, I'll prefer Spring Boot
Yeah.
because I've already done this with Node.js.
Mm-hmm.
I have also shared that video. It's there. The video is also there for how to do this in. But yes, I did not covered all the concepts of Kubernetes there because you do. I did this with some simple use case. So, but
Okay.
yes, we can do it in more detailed way in these sessions.
Sure. Great.
Awesome. So, yes, so today I will give you a homework that
Mm-hmm.
probably these are the topics which we are planning to discuss. If you see that, okay, there are something which is interesting which I missed out, let me know, right?
Yeah, absolutely.
Right. So basically,
I heard Ham, Prometheus, Grafana, these term first time. Yeah, so but apart from that, YAML and Linux, Docker, Spring Boot, yeah, these terms I'm aware about because
yes,
I have I have worked with Docker before, not so much, but but, but just like for the POC purposes, but how to write Docker file and
yes,
how to how to use Docker Swarm for to spawn multiple dockers at the same time or multiple to uh, up and down the different docker machine. Yeah, so I have done that, but uh,
great.
but 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 I double check the ham how what are these terms and how they
Yes,
are contributing in Kubernetes. Yeah,
correct,
I will
correct.
double check this one.
Because I believe, yes, if you have the understanding of all these topics which I shared,
Yeah.
this will make you an expert in Kubernetes, because now Kubernetes is in very high demand.
Yes.
And if someone has a basic certification of Kubernetes, actually, Kubernetes, yes, one important thing also I will share is the Kubernetes, there is cloud native foundation. This
Mm-hmm.
is what is the governing body for Kubernetes. Okay, so let me give the name of this, because Kubernetes project is driven by, it's an open source. Initially, it
Yeah.
started with Google,
Mm-hmm.
but now it is part of cloud native. This one, just I'm putting this Cloud Native Computing Foundation, CNCF,
Yeah.
right? So if I go to their website, so there are some certifications also which you guys can do this from this site. I'm just sharing. Hope now the site is visible. Cloud Native Computing Foundation, which is what I was talking about.
CNCF.
Yes.
Okay.
So there are certifications also which are there in this sites which can be done, so that you also get skilled in Kubernetes. So here,
Yes. Okay, so Kubernetes certification are basically for like the person at every level, or it's something more demanding at the person who is solution architect, or maybe it's an SD 3S, or yeah,
I
or
would say it's now a must for everyone,
okay,
because
even as a manager role also.
yes, Kubernetes certificate. See, knowledge is important.
Yes.
If you have certification, then you have additional edge, right? So I would recommend that, yes, if someone can be a certified Kubernetes professional, basic level,
Hmm?
this is a good point, because then your resume will shine over rest of the crowd,
Okay, but
right?
but I think Tarun, one doubt I have regarding like at the people who are at around 14 year or 15 years of experience, yeah, because I'm still in this in a in a situations, yeah. So I also want to discuss with you. So the people who is at 14 year, 15 year, maybe that person will be at a level where he is engineering manager, yeah.
Yes.
So the the main responsibility of that person would be to manage the team and also manage the maybe managing the team and manage the delivery is the most important thing, but apart from that, like any features they want to design, because in every company there is also a solution architect team is also is there, so that is the job of the solution architect is to provide them a good solution, and those people are good in AWS Kubernetes because they are actively daily deals in these things. So, but as a EM, as a engineering manager, are these things really matter that like because after 14, 15, how much part that he will deal into this kind of technology like the person who as a solution architect is dealing.
Yes. No,
Yeah.
you need to be technical at all levels
Hmm.
until I would say yes. If you are into the technical stream, you need to know all these technologies, because if you are not aware of, then you won't be able to manage, because you have to find all decisions. See, assume you have a very good solution architect.
Yeah.
He does a bad design.
Hmm.
Who
Okay.
will be blamed? As a engineering manager. So if you are the engineering manager, you will be blamed,
Absolutely.
right? Not this guy. So how can you avoid that? You don't do a bad design, or you do not approve a bad design,
Hmm.
is only by learning the technology. So you
Okay.
don't need to be expert,
Yeah.
but you need some understanding so that you can make a decision. If you have not heard all these terms,
Hmm.
definitely you are not in a stage of deciding it.
Absolutely.
But yes, if you have done some simple application, right,
Hmm.
in the real world, you will be able to make sense that yes, this is done thoroughly or this is not done thoroughly, or are the team going in the right direction or the team is not going in the right direction, right?
Okay.
So
Okay. Yeah. Okay. So for that position, I think so. The understanding of these terms, or maybe the understanding of the whole functionality, is important. But
but
for
yes, you cannot
engineers,
understand things without doing it.
no, no.
Yes.
Without doing, I don't think that it's possible, because at least we should
Yes.
have some practical things.
Yes,
Yeah.
practical is
Yeah.
important, because otherwise you will not be able to retain things, digest, right? Digestion, for digestion you have to do some practical.
Yeah.
So
But
what I
I'm
would
getting. Yeah. Go ahead.
yes,
Sorry.
see
Go ahead. Yeah.
see, in higher your responsibilities are,
Hmm.
more is the expertise which you should have.
Hmm.
So you are a manager. That means you have to be a good person technically, plus you have to be good person in management also. So you should know all the people management skills,
Hmm.
but not at the cost of not knowing technology,
Yes.
right? Because you are dealing with technology, so the understanding of technology is a must. So for engineering manager in technical companies,
Hmm.
you need skills, technical skills,
Yes.
because otherwise, you will not be adding enough value to the team, right? Because otherwise what you will be doing is maybe approving leaves, approving trainings, approving right, purchases of various items, doing team lunches, organizing team lunches, which your team assistant can also do,
Absolutely.
right? So you are a
Getting.
manager or engineering manager, so that word engineering is there. You need to have good understanding of all the technologies which are used. So since you have more responsibility, that means you need to have more knowledge rather than limited knowledge. So engineering manager should be a person who has the maximum knowledge in the team.
Okay, but I think Tarun, for example, in a service organization where you are engineering manager and you are good in Java, Spring Boot, and all the AWS, rest of the thing, but maybe you got a project that deals in Node.js, and
Yes.
apart from AWS, they are using some Azure. Yeah, but yeah. So in that scenario, because you are good in Java, so basically you are good in terms of the concepts, how the architecture should be, and how the maybe how the the new API should be written, because only the language is changed, but the syntax concept are
Yes.
still the same. Yeah,
Yes.
yeah. But I think in that point of view, maybe you are good in to architect and designing, but maybe you will not able to help them in terms of the technology. Yeah.
Yes, yes. Right. See, you should know one car, right? If you are a good driver,
Hmm.
say, assume you are a manager, right? In a,
Hmm.
say, Ola or Uber,
Yeah.
and you have, say, Swift, you have Desire, you have a lot of other vehicles,
Hmm.
right? Maybe some automatic gear vehicles, some 5 gear, some 6 gear, 4 gear vehicle.
Hmm.
You need to have good understanding of driving, because you need not have to drive each and every vehicle,
Yes.
because you are an engineering manager. You have, so the person who is driving that, he needs to know in and out of the vehicle he is driving.
Hmm.
But you need to know only driving one vehicle, four wheeler. You can't say, oh, I only know two wheelers, so I can manage all the drivers, because then you will not understand the problems which may come in into four wheelers.
Okay.
Right? But yes, so it's like, so you do one technology fundamentals, but see, there is a difference between title and your role.
Hmm.
So you were talking about that in some companies engineering managers are only doing project management.
Yes.
So see, their title is different and their role is different. I'll not call these people engineering manager, I'll call them delivery manager or project manager.
Yes.
Right? Title does not matter, title anyone can get. But
Absolutely.
roles and responsibility, for getting roles and responsibility for engineering manager project,
Mm-hmm.
you need to know the technology.
Yes.
Right? So assume you are working in some organization where some new project is there on Kubernetes.
Mm-hmm.
You go to the director, ask him, give me the project on Kubernetes. If you do not know the technology, director will hesitate to give you.
Yeah.
But if you have certification in Kubernetes, or you have some understanding knowledge, because if you don't, if you have not worked in any project on Kubernetes, again, you, how can you prove that you know Kubernetes? Because director may not have the time to conduct a test for you. You
Hmm.
can simply say that, yes, I am a certified Kubernetes professional, I can handle this project. That's it. You will get that project. So here the technical expertise can help.
Hmm. Got it. Yeah. So I think that's why the system design concepts are
Yes,
like yeah,
yes.
I think the base
Right, right.
for every role. Yeah,
Right,
because
and
doesn't
definitely
matter.
in
Yeah.
organizations, I do understand. Not in all organizations you have to be an engineering manager, because in
Yes.
service organization, engineering is taken care by the client.
Yes. Absolutely.
So the engineer or managers in service organizations have to be good in project management. That's what they have to do, because they don't have a scope of doing engineering management, because the design is given by the clients
Hmm.
or whatever. But yes, in case you have project where you have to design, generally in greenfield projects you have this opportunity, right? If you are working in a service organization and you are working in a greenfield project,
Mm-hmm.
right, that means you are starting any project from scratch, then definitely you need these skills, technical skills, because you have to do both technical decision making as well as delivery.
Yeah. Get it.
So yes, it's important skill. The technical skills are very important for managers.
Hmm.
So, yes, maybe right now, based on your project, it may not be important, because if it's a maintenance project, that
Mm-hmm.
means no, someone has already designed it. Now you have to operate it and
Yeah.
bug fix, and then it may not be required. But sooner or later, you will get into some project.
Yeah. Where everything is
Right,
required.
so I would recommend everyone to keep upskilling.
Hmm.
even if there is no requirement right now, because you never know, tomorrow something may come up. Yes. Now
Yes.
world is very dynamic, right? So things are changing in geopolitics very quickly, and we were thinking positive signs in the market. We felt that yes, in next few days, but now new developments are happening which are negative sides also, right? Correct.
Yeah.
So yes, you never know. Earlier we had only one place where there was trouble. Now there are two places in the world where are troubles. So it's better to be
Absolutely.
more flexible, correct?
Yeah.
Because the business is now tricky.
Hmm.
So yes, more skills you have, then you will be more flexible and you will always be in demand, and you can get into many projects. So I would at least, so maybe 5 years back, not many projects were having Kubernetes, but now every project will have Kubernetes, right?
Yeah,
So
absolutely. Because most of the poets now, every poet is a kind of, it's a distributed.
yes,
Yeah,
yes,
and where this distribution is came into picture, these terms will always will play a great role.
correct,
Yeah.
yes, yes, because I have many friends in many
Hmm.
mentees also in various service companies. I ask them what is the skill maximum number of people are looking for,
Hmm.
right? So most of them, all of them, almost all of them, they said they are looking for learning Kubernetes,
Oh, great.
and they are planning to get certified on these also, because they believe that yes, certification also is very easy to share your
Ab-
accomplishments or knowledge.
yeah, absolutely.
And
I think,
definitely, if someone
yeah,
is learning, say, what I would also recommend to everyone is, if assume you know Java,
yes,
get Java certification, because that's
yeah,
very less effort. Yes, maybe something you are missing, you will also test your knowledge.
mm,
If you know some technology, say you know AWS, or you have been working since many years, give
mhm,
AWS certification. It's not urgent, but consider giving as early as possible, because this will improve your profile. So
yes,
if someone has already learned the technology, why not just get the certification?
mm,
Sometimes you get good discounts on certification. Watch out for discounts. Watch out for, sometimes your companies may sponsor this, or you may have some learning quota in your benefits which you can utilize. So if there is some quota learning thing, utilize it, because these are all long term. Immediately you may not see the results, but you never know. Maybe 4 years, 3 years, 5 years down the line, this may become game changer for you.
absolutely. Yeah, completely makes sense. Yes, and for the Kubernetes, I think the CKAD is something that like for the developers or maybe for
Yes.
the technical person.
Yes. So first one, you go with the basic. Don't have to
Yeah.
do the very advanced one, because that is not required for engineering managers. That is required for people who are only focusing on this technology.
Okay, CKA, Certified Kubernetes Administrator.
Yes, yes, right. So I would say first one you do, which is at the very beginner level.
Hmm. Okay, this is for
CKA,
okay
CKA is good. Yes, no
CKA.
need to worry about. There are 70 certification. This site says, right.
Yes.
So correct. So the next one, CKAD is fine, but see, you go with the next level if you have rest of the people in your team. The idea behind doing the certification is, as I said, outside or shine above rest of the crowd.
Yeah.
right? So if there is not many people CKA, if you already have everyone CKA certified,
Then go for CKD.
no, sorry, here CKA is administrator. You
Yes.
have to do AD. CKAD, you are an application developer. So they
So
are different streams,
okay. So
right?
CKA is mostly for the DevOps profile.
Yes, CKA is for DevOps profile.
Okay. CKAD when you are into the coding, and
Yes,
you also man okay, or a part of the solution architect if you are.
yes, yes.
Yeah.
Right. See, what I would suggest is do this one, associate,
Associate.
because you have foundational skills and knowledge.
Associate CKA.
C, K, C, and A.
KCNK. Okay.
This one, K, C, and A. Yeah.
Kubernetes and Cloud Native Associates.
Yes.
Okay. This is for foundation knowledge and skills in Kubernetes and the
Yes,
wider
yes,
cloud native ecosystem.
yes. For engineering managers, I will suggest this one.
Okay.
Yes.
Great.
Right. So,
Sure. Yeah. I think in this your Kubernetes session, and along with your Kubernetes series, I will get in touch with any Udemy or any other online Kubernetes courses,
yes.
so that, and after that I will plan for this certification. Yeah.
Correct. Yes,
Yeah.
that would be good. That would be good.
Yeah.
Because I'm also writing a book on Kubernetes. So,
Oh, awesome.
so yes, I can share you that book going forward once
Mhm.
it's out. But yes, that may take me 4 or 5 months to write.
Okay.
Right, so
Great.
it may
Yeah.
come next year only. But yes, this year
Mhm.
we can kind of keep discussing on various topics of this. I've written 2 books already. One on the Spring Boot, which also covers a lot of Kubernetes. That would be out in a month's time.
Mhm.
And another book on cloud native computing, which will be which is already available out in the market, right?
Cloud native.
Okay, the book I will give you just a minute. So this book is what I was talking about: beginning cloud native development with microprofile, Jakarta EE, and Kubernetes.
I think I can only see the Google Doc.
You are not still seeing? Okay, let me
Yeah.
share this again. Just a minute.
Okay. Beginning cloud native development with microprofile, Jakarta EE, and Kubernetes.
Yes, absolutely. Right? So, yeah, this one. Yes.
Okay.
Yeah.
What
This
is
book.
Jakarta?
This book. Java EE, basically. Java EE is called Jakarta EE these days.
Okay. Java Enterprise Edition.
Yes, Java Enterprise Edition.
Okay. So
And
Jakarta is different than Spring Boot, or like
yes,
now Spring Boot is famous is
yes. It's merging. So
okay.
now it will be the same thing because the APIs will be same. So a lot of
Okay.
components which you use in Spring Boot,
Mhm.
Java persistence
Yes.
and right. So they are. So basically, yeah, this is the book. No, I wrote on Java EE microprofile Kubernetes. Microprofile is another framework which is more advanced than Spring Boot
Mm.
because Spring Boot is old. So There is something called micro profile.
Oh, okay.
Yes,
So
which is,
micro profile is also a web framework.
yes, like Spring Boot. It is for writing microservices.
Oh, okay.
And this is also, see here, this is for microservices architecture. 6.0 is the latest version. Right, so people are not aware of a lot of technologies which are out there, and because of that I am writing all these books, because it takes a lot of effort if you are not using the right technology or framework to build any application.
Yes.
So see here, this is Jakarta EE, right? So it has a lot of components in I have covered topics from here which are relevant for microservices and for doing cloud native enterprise development, right? So now it's all about cloud native development. Cloud native is nothing, building application in containers on Kubernetes so that you can deploy it in any of the platform, right? Because Kubernetes, when you deploy, you get portability. You CKS, you can run it on CKS.
Mhm.
Google Kubernetes service is also there. Everyone, Amazon also supports Kubernetes, so you can run their applications everywhere, right? So this is, so
Got
the
it.
Spring Boot book which I was talking about is this one. This is something which I have written. It will be up in market soon. Right now it is in
I mean,
printing stage.
I can only see the cloud native computing foundation screen.
Is it okay?
Yeah.
You are seeing the other tab also? No.
No, no, no. Only the single tab is there. One tab is.
I think this is a bug where I am sharing window, but it keeps,
Are you in Firefox?
no, Chrome.
Okay. I think Chrome. Maybe some
But on
because
Mac, yes.
yeah.
So I choose the Windows tab and then I say,
No, I think it should have.
okay, window. Okay, window I'm choosing, so I should choose screen.
Yes.
Ah, okay, okay, got it, got it. Yes, was my mistake.
Yes.
So
Microprofile Jakarta E in
yeah,
Kubernetes.
this book is what I wanted to share is this one. This is the other one.
Microservice. Okay. Spring Boot 3. Yes. Yeah.
Yes, yes.
Latest
This is
framework.
with the latest Spring Boot 3. Yeah. And here I have covered again cloud native, which is Kubernetes. I've covered event driven architecture also.
Mhm.
So I have also covered here domain driven design.
Okay. Okay. Tarun, can you give us a session on domain-driven design? Yeah. Because
Sure,
because
sure. I
I have
can
heard
give.
a lot about this term. Yeah.
Yes.
In terms of microservices, but I
Yes.
never had a chance to dig
Sure,
into this.
sure.
Yeah.
We'll do that. I gave already a session on domain driven design.
Okay. So I'll check the recording. So in that
No,
way,
but I could not record fully. There was some technical glitch. But yes, I will share some part of the recording, and probably I'll do again this domain driven design, because yes, many other people are also requesting.
okay.
Yes, so we'll do that, right? And yes, definitely in that session I also did not covered everything, but it is good if we are doing some project kind of stuff, then we do it via domain driven design, so everything will become a part of one project, right? We'll apply domain driven design, we'll apply containerization, cloud native concepts, and we'll apply Spring Boot 3 also.
Okay.
Awesome.
Great.
Great. So we can now close this call, I think.
Absolutely. Yeah. Thank you,
Perfect,
Tarun,
perfect.
for
See,
your
yes. Maybe,
guidance.
yeah,
Yeah.
I'll
Now
also
the
increase the number of sessions, because was busy for last few weeks. But yes,
Yeah,
now I can
absolutely.
increase the number of sessions so that we can cover multiple technologies.
Sure.
Awesome. See
Thank,
you. Bye.
thank you, Tarun. Yeah.
With one, say for example, message queues, right? So that's why I kept online game or some other another